I followed in my father's footsteps by choosing a career in computer science. That's what he had studied, and even as a child, I thought it was cool and was interested in it. Since I was young, I've always had exposure to computers and have been playing around with them, so that early start is probably where my interest began. Eventually I started to discover what someone could actually develop and achieve with computers. That aspect of it was so fun for me that I decided to study software development. In the world of computer science, there are two different areas in which one can specialize, either front-end development or back-end development. The front end is focused on creating human-machine interfaces that look good and are easy to use. Back-end development is more about building the logic behind all of this. You have to be able to map properties and write functions to do things. Front-end and back-end are the two existing development worlds in computer science. As a programmer, I try to create an interface between human and machine. I want the human to be able to effectively operate the machine. That is my ultimate goal as a developer. I'm fascinated by the complexity of computer science. Because of its complex nature, I can find myself spending days and nights developing apps or driving hardware for makers to move servo motors or to turn a light on and off via a motion detector. It sometimes seems that you can't stop once you start these types of projects because the development is so much fun. Programming can also be creative. With programming, you can let off steam, and in some ways programming can be compared to writing a book. There are countless languages that can be used, and within those languages 10 times as many different applications can be created. But it is also a very structured way of being creative. You can't just write a bunch of crazy things down and hope it works. You need to hone your creativity with a programming environment. When I develop new software, there are certain procedures to follow. First of all, I have to determine what the software needs to be able to do. So in the beginning, I define everything that needs to be implemented. Then I have to contact the mechatronics engineers. For example, if it's software that can be used to control a robot, I need to know what you can do with the robot. The mechatronics engineers can give me this input. I can also get help from designers to talk about design aspects to improve the look and feel of the software. Getting input from these two different sources can help to create the best possible program. Bionics inspires me with innovative projects that are rarely found elsewhere. Where else can you find little ants that walk around autonomously, or the bionic cobot, which is based on the human arm? It's amazing to have access to and be able to play with such robots, and it's all because of Bionics. It's all very fascinating. To study computer science, you have to be very good in mathematics. Structured procedures where you solve mathematical formulas help you a lot during your studies. In addition, you have to be enthusiastic about getting involved with complex challenges and situations. There can be situations where you're facing a problem that no one has ever faced before. While these types of difficulties may present themselves, developing solutions for them can be enjoyable and rewarding if you like computer science.